Alright, so we were working on creating a repository. So what we'll do is, I'll start from scratch. We'll build a new repository from the beginning. Okay, so just to recap, um, our the development is a three-step process. One, develop the repository, or I can say build repository. Right? Once the repository is developed, we need to deploy the repository. So develop the repository. Next, you need to deploy it, and the third step is report. Right. So for the development, what do we use? We use OBIEE administration. This is the tool that we use for the development of the repository. And for the deployment of the repository, we use Enterprise Manager. So this is a cloud, I can say. Cloud means it's based on a browser. This is using the analytics. This is also a cloud, which means the second and third are purely built and developed using the browser. The first one is on the small Windows GUI utility, which I call it as an BI administration. Right. So we'll be building a repository now, and then we'll see how do we use this repository and how do we deploy this repository, and based on this repository, how do we create the repository. So this, just to give you, this is a three-step process. So we are working on the first step, so building a repository, and we'll be using the BI administration. Right, so I go to the start menu, and if you look at the Oracle Business Programs, within the programs you have the Oracle Business Intelligence install. Right, so you have the BI administration. Okay, or if you want, you can keep it as the menu item also. So see, I see the BI administration as a menu because I can add it, right? I mean, this is a basic Windows thing. You can right click on it. You can say something called unpin to start menu. If you say pin to start menu, something like that, then you'll have it in the start menu. Okay. So this is your administration tool, BI administration. Right, so this is your administration tool, which is an empty now. So all we have to do is we have to create a new repository. So the repository is going to be created with an extension .rpd. Right. So from the file menu, I say new repository. I'm creating a new one. Okay, so I can create a repository with any name. Guys, whoever is not on mute, could you please mute your mics, please? Kavya. Okay. Alright, so you can create a repository with any name. Suppose say I can say sales repo. So I'm creating a sales repo, suppose say 001. So I can give any name, sales repo 001, which is going to get created in a location. This is the location where I'm gonna copy this location and keep it in a notepad for our future reference to understand where this file is created. Right, so I'm creating a repository where the repository is going to get created in a location so and so. Okay, so now it is asking import metadata, yes or no. So I'm saying no, which means within this wizard I'm not interested in importing any structures. All I want to do is simply create a very basic repository. Probably I'll do the structure import as a later part. Okay, so now the password of the repository, which means when you're creating a repository, you're setting a password also. So which means tomorrow if somebody or you also have to open this repository, you need to provide this password, then only you'll be able to open the repository. Okay, so I'm creating a password. I'm setting a password for this repository. So this repository is a password protected now. This repository is a password protected. There is no username, only password. So if you are opening the repository, it will ask you, give the password, then you give the password and you can see the content of the repository. So I can say finish and my repository is created. So with the three layers, physical, BMM and the presentation. Now all I'm going to do is I'm going to import my structure. So where are we going to import the structures from? We are going to import the structures from a user that is already available in our database, which I call it as a BI sample. BI sample is the user. Within the BI sample, we have a couple of tables where we can make use of those tables. So what are those tables? So we have tables like products, um, offices, revenue. So we have a lot of tables. At this point of time, we are going to create a repository with these three tables: products, offices, and the revenue. Right. So now let's go to the repository and import those tables into our physical layer. So physical layer is basically what we have. So whatever that we have in our physical database, which is already available, we import that into the physical layer. So that way, I am actually representing what is that currently exists with me. See, reporting is what? You have some information, right? So based on that information, business users want to analyze some data. It's like maybe they may want to understand the profit percentage or margin percentage. So they may want a number of metrics, right? So based on whatever that you have, you are trying to create something that is required by the business user. So before I create something that is required by the business user, I need to present what I have. So that's what the physical layer does. It represents what you already have in your system, in the sense in your database, in your operational system, which means you're capturing this data using your day-to-day transactions, right? So that data you're capturing, and you're saying that, okay, I already have this data. So now our objective is to create something that is required by the business user, because they may want a very exhaustive report with a lot of calculations. So we need to build those calculations. We need to create those required data and present it to the user. So we start with the physical layer and we import our structure. So I go to the file menu and say import metadata. So when I say import metadata, I'm importing the structures of my tables, not the actual data of the tables. Okay, so I go back to my connection type. So I have the different options to connect and import my structures, and I'm going to use the connection which is OCI, which is Oracle Call Interface. Okay, so Oracle Call Interface is a driver which will help you to connect to the Oracle database. So it is provided by Oracle itself. You don't need to worry about installing any drivers or anything. It's pre-built. All the drivers and everything is available. All you have to do is simply provide the parameters that is required. Okay, so using this driver, if I have to connect to Oracle database, I need three things. One is I need to have a data source name. So in my system, the data source of my Oracle is ORCL. In my system, my data source of my Oracle is ORCL. And the username is BA sample, and my password is also BA sample uppercase. Okay, right. So this is my user, this is my password, and I say next. So what does this import metadata wizard will do? It will connect to my database with the ORCL that is available in tnsnames.ora file. It will look for the location of the database that is running, and it will automatically connect to the database with the username and the password. I say next. Now when I'm connecting, it is giving me an option. What do I want to import? What do I want to import the metadata? So select the metadata type. So what is the metadata type means here? Table structure, key of the table, and a foreign key. So if I am importing two tables, what does it will import? It will import the table, which is the structure of the two tables, and the primary keys of the two tables, and the relationship between the two tables. So if I import two tables, if they are having a keys and if they are having the relationships that is available in the database, it's already available in the database. What it will do, instead of you recreating them here, my administration tool itself will automatically import the tables and the keys and their relationships automatically. Okay, if they already have. Okay, so at this point of time, we are interested in importing these three. We also have additional things. We'll see it later. We'll import my three options. Okay, so now I have an option where I can look at my BA sample. You see, I have a BA sample here. This is my BA sample, and within my BA sample, I can see a lot of tables here. So one is the products as usual, and other is an offices, and the other one that I was talking about is the revenue. So I have three tables, which is products, offices, and the revenue, uh, which I'm going to import. So now when you're selecting that, when you're holding control button and selecting, make sure that you select only these three. If you select any other schema, if there is anything selected here or here or here, everything will be imported. So you just need to make sure that only these three are highlighted. Okay, and say import selected. So now you are asked to create a connection pool. So connection pool is connection information that is captured in your repository. So why is this? Because when you're importing the structures, right, you need to know where you're actually importing from. Why? Because tomorrow when you have to get the data in the runtime, because the idea is what use these tables to pull the data, right? So you need to know where exactly these tables are available. You need to capture those connection details for the future reference. Okay, so now you can give a name or you can keep it the name connection pool as it is, doesn't matter, but again just try to give some reasonable name. Suppose say if you want to give the base sample, I can give base sample. So this, it's your name, you can give any name. I click OK. Right, so this is your schema and this is your tables available in your schema. So 1, 2, 3, three tables imported as a finish, and you have um, you mean how to import base sample tables to the database, Senthil? I'll give you the script and
Yes, Dinesh.
yeah, I'll give you the script end of the class. I'll tell
Oh,
you.
so we did it right.
Yeah, so I'll send you the script. At the same time, I'll walk through the script what you guys need to do to import, so that you have them. Right. So now I have three tables imported, and as we discussed, when we import the structures, what does it will do? It will import three things. One is a table, and the second thing is the key, and the third is the foreign key. In the sense, if I have input three tables, it should import the tables and the keys and the foreign keys, which means the relationship between the tables. If I see here, no key is imported. See, the reason is, my database itself doesn't have any key. My database itself doesn't have any relationship. So, though you have selected the option key, foreign key, but if the database itself doesn't have any key and the foreign key defined in the database, you cannot, there's nothing it can import, right? So, um, though we have selected three options, it just imported the table structures for us because the BA sample schema is provided with the tables without any keys and the relationships. The reason is Oracle wanted us to create the keys on our own and kind of learn the things. So it's kind of um, an exercise for us, right? So they have not provided the key, so we can create our own key. Yeah, repository also supports the data files. Yeah. So it can have a data files like it can have the database, or it can have flat files, it can have Excel, or it can have the different sources. So your physical layer can pull the data from the different sources. If you look at here, import metadata, we have only used the database. Now say your this can also get the data XML, SBase, XMLA, ADF, OLAP, Hyperion, SAP. So you can use any of these sources. And again, the ODBC is a generic in the sense, any application or any system that can connect through the ODBC, you can connect and you can import the structures. So these are the different sources it will support. We'll see all those. We start with the database and we'll see the other sources as well. Right. So I have three tables imported and with no keys. And the first and foremost thing that I will be doing is I'll be defining the keys. Okay. How do I know what are the keys? Basically, I need to know. So I need to have the very basic understanding of what are the keys of my tables. Okay. So if you look at my office, probably no office key is the key. I mean, definitely office key is the key of this table. At the same time, if you really want to know what is the information that I have so that now I can decide what key is, I can right click and I can say view data. Remember, when I say right click and view data, don't think that this data is available in this particular repository. My repository doesn't have any data, it's only a structure. So if I say view data, what it is going to do? It is going to connect to the database using this pool. It is going to connect to the database using this connection pool. Okay, and pull and display the data to you. So it's a view data. It is displaying the data where I have, this is my office key. Like, 1, 2, 3, 4, 5, 6, up to 6. This is my office key. So I'm going to define my office key as the key for this particular table. Okay, so how do I define a key? I double click on my table. I double click on my table. It's a physical table, right? So on the key tab, I can go and create a key name. So office, it's just a name. You can give any name. And from the columns, you're going to select what column? You're going to select the checkbox for the column office key. And you can give any description if you want, otherwise it's fine. So this is my office key. And for the products, I'm gonna define my product underscore key as the key. So double click on my product. And if you see, remember, if you already have the keys in the database, you don't need to. So that's one thing that mostly when you're importing the data from the real-time systems, right, there is always keys, there is always relationships. So you don't need to do all those things. But in case we are doing from the worst, in the sense, if there is nothing, how do we get started is something that we are doing. Okay, so then I can say prod key. This is my product key. And the column that I'm going to choose is prod key. Okay, so for the revenue, I don't need to define any key. Basically, it's a fact table. Yeah, it's going to create a unique keys. Yes. So it's just a normal primary keys. It's going to create unique primary keys. Okay. So revenue, I don't need to define any key because this is more or less like it's a foreign key table. So you have the prod key here and you have the office key here. So basically, you'll be linking the revenue to the office in the product. So it doesn't have any primary key. If you want to create any key, also it doesn't matter. You can create with some date or something, because bill date or ship date, because it's the numbers, right? So we'll be creating it. But let's not create any key for this table at this point of time. So what I did is, out of 3 tables, I created keys for the 2 tables, which is the product and the offices and the product. So now I need to understand the relationship between these tables, because I need to define how these 3 tables are related. Otherwise, what happens? I can get the data from the individual tables, but I cannot get the data, a combination of these 3 tables, right? Suppose if I have to query the source with this combination of 3 tables, the minimum and the basic requirement is what? These 3 tables should have relationship. These 3 tables should be related. So one beautiful thing here is, though my database doesn't have any keys and relationships available, but I can define my own keys and relationships inside my OBIEE, and I can make a query accordingly. So I still pull the data based on the combination of these 3 tables. So what I'm going to do is I'm going to define the relationship between these 3 tables. Suppose say, right, this is my base sample, right? Right click on the base sample. If you see, there is something called a physical diagram, objects and all giants. So what are the different tables that I have, right? I can select, it will show all the tables. Okay. Suppose say if I say right click, if I select these 2 tables, if I say right click, physical diagram, if I say selected objects only, which means it would display the relationship between only those 2 tables. Okay. Objects and direct joins means these two tables and any table that is linking to these two tables is something that it will display. If I select object in all joins, it will display all the three tables. Okay, it's displaying only two. Right click here, objects and all the joins, it will display three tables. Okay, so now I have three tables. This is a relationship kind of a diagram where we can define the relationship here. Suppose if I want to make it a little bigger, I can zoom in. Right. So now all I need to do is I need to understand how these three tables are related. So it is a basic thing that we need to know. We need to know and we need to do. Otherwise, what happens? It's very difficult. So the tool itself cannot do anything. So it cannot really identify how these tables are related unless you import them with the relationships. Because it expects you tell the tool saying okay, tell me what type of relationship these two tables have. So that is something that we need to give and explain to the tool so that it can create. So I have three tables. I have an officers table, I have a products table, and the revenue table. So now I need to see the relationship between these two tables. Suppose so officers and the revenue. If you look at here, when we're looking at, we have seen that there is a office key available in the revenue. So which means they both have the relationship between them. And so, I mean, there is the data that is related, that is available between these two tables. So that is where we create the relationship between the table. Okay. Now, so how do I create a relationship between these two tables? Okay. So if you see here, so there is something called a new join. So one thing that you need to remember, there is no magic that you can do here. There is there's nothing specific to OBIEE that you do here. It's purely a database relationship that we need to understand. So it's a hypothetical scenario where we have three tables, and before we are creating these tables, before we are doing anything here, we are analyzing what are the three tables and what is the relationship that should be there between these three tables. We should know beforehand, then only I'll be able to create. Otherwise, I come here and I try to do something, I'll not be able to do anything. There's nothing that my tool can do. So we need to have a basic understanding what tables we have and what is the relationship between the tables. Then we have to come to the physical diagram to represent the relationship. So don't think that how we are doing this. We are doing this because we know that these are the tables available, this is the relationship between the tables. But again, these kind of things doesn't really occur when you actually work in the real time, because when you import with the keys and the relationships itself. Otherwise, they also give you a ER model where it explains the tables and the relationship between the tables and the keys and everything. So you follow your diagrammatical representation along with the lines of the ER diagram. So entity relationship diagram they'll provide. So at this point of time, we are everybody. We are developer, we are architect and everything. So we have to understand our own tables. We have to understand the relationship between the tables on our own. Okay, so now I'm going to define the relationship between these two tables now. So there is a option for a new join. I'm going to create a new join. So I'm going to connect my revenue to offices. So when I'm connecting revenue to offices, so it is automatically identifying from the offices table, it has chosen office key, and from the revenue, it has chosen office key. Because I have a key, right? It is searched for the same key in the other table. Since it has found the same column name, the other table, it has automatically defined the keys. That is an advantage of defining the primary key in your offices. Suppose without defining the primary key in offices, if I try to create a join, does it allow? Yes, it will allow. But you have to specify which column in table to which column in this table. So that way, it will create the primary key for this table automatically. So there's two-way process. One, you create the key for the table and connect it. Otherwise, you come here and you connect and you select the columns. Then it will automatically define the key for you. So two things, either of the options you can choose. But one more thing that you need to choose here is that there is a cardinality. If you look at here, what is the cardinality for the officers? 1. And what is the cardinality for the revenue? It's n, which means 1 to many. This is a 1 to many. So who's on the many side? Revenue is on the many side. Who's on the one side? Offices is on the one side. So 1 to many. If you look at here, one office can have many revenues. Right? Suppose a office can have many revenue entries, right? So that is my relationship. Okay. In the sense, I mean, there may be many revenues generated by office. Suppose if let's take it as a bank. So there may be many deposits happen, right? So it's a one to many. So one office can have the many revenues. So with an office key, I can have the many revenues to be keyed in. Okay. So that is the type of relationship between these two tables. So again, now I need to link my revenue to my products. Here also, it has automatically identified my product key as the key from here, and from the revenue table, it's automatically identified my product underscore key. And again, it is a one to many, one to, which means one product can generate many revenues. Obviously, right? So suppose if I have a Colgate, my Colgate may be sold a number of times, right? So one to many. So my product can be many times in this revenue table. Here, my office can be many times in the table. That's pretty much possible. Can the join define based on the function of the column? Exactly. I mean, it's up to you. So there is no hard and fast rule like the joins has to be defined like this. So it totally, suppose we just have three tables, right? So probably there is a complex set of tables like 10 tables, 20 tables, where you need to define. Yes, you need to understand the functionality of the application, or you need to understand the kind of what is that you are really trying to pull. So you need to define the relationships accordingly. So you have the flexibility to define the relationship on our own. Suppose say now I'm connecting from revenue to offices. So which I am explicitly mentioning my revenue is on the many side, my office is on the one side. So because my data is kind of represented that way in my database. Now I am defining that way. Suppose if somehow I decided no, this is not the relationship, this has to be offices and the revenue, where offices has to be on the many side, no problem. If you drag and drop from offices to revenue, it will create offices on the many side, it will create revenue on the one side. So you are intentionally doing it if you have a reason. So you have the total liberty to define the relationship in a way that you want to represent, because remember, based on the way you represent, your fact tables and your dimension tables and all these things will change automatically. Okay, so that you have to be a little careful. Yeah, you can define. Yeah, you can define. You can do substrings and all the stuff, so you can control. We'll see those things when we create an alias tables. Oh, there's one more. Okay. When we are defining a key in repository, and if the database is having duplicates for the key, will it work? Uh, yeah, I mean, see, when you're defining something here, right? So you need to understand one thing. When you're defining something here, these keys are logical only. I mean, in the sense, suppose a offices doesn't have a key in the database. So if I'm defining an office key, does it create a key in the database? No, it's not going to create any key in the database. So database still doesn't have any key. But when we are sending the query, right? So my query is generated based on these three tables because they are having a relationship inside the OBIEE. So OBIEE will send a query and will pull the data from the database. Unfortunately, if I have duplicate data, the duplicate data will be pulled. So that is something. So it doesn't really create a key in the database. It just use that key here. Okay, so now I have three tables where I have imported three tables, and where I have defined the keys and I have defined the relationship between these tables. Okay, now, so what I need to do is I need to create a business model here where my business model talks about something that I need. So this is something that I already have. So it's kind of more or less we are only representing what I already have. So if, fortunately, if there are tables, if there is a key and if there is a relationship, we do not really need to do all this work. All we do is simply import these tables. Keys are there, relationships are already there, and you have three tables ready with the keys and the relationships. Since there are no keys and relationships available, we had to create on our own. Okay. Now, the main objective of our repository building is we would like to create our own model. So basically, this business model, in the sense, is a multi-dimensional model. So a multi-dimensional model, if I have to give you a heads up, what is a multi-dimensional model is basically when you are building a reporting application, right? So reporting applications are always built on the multi-dimensional models, because a multi-dimensional model is a best way of storing the information, if I have to put it in simple. Okay, so there are certain standards, right? When you talk about the standards, there is a lot of standards that is available in the market, like an ISO standard, this standard, that standard. Okay, so now what are these standards are? Basically, standards are best practices where they define saying, okay, if you do this one, it is good for you, or this is something that is being used by everybody and they have tested it, it is working fine. So it is working for 100 people, definitely it will also work for you. That's kind of, they define. So when they build these tools, right, suppose whether you take it as the OBIEE or Cognos or any tool that is available in the market, they are built on the same standard, which we call it as an OLAP standard. So what is an OLAP standard talks about? So OLAP stands for Online Analytical Process. OLAP stands for Online Analytical Process. Now, what is this? This is a standard, suppose like a traffic signal. So we have a traffic signal. This is a standard. So it is implemented by whom? It is implemented by every state in US, assuming. Okay. So why every state is US is implementing the same traffic signal colors? Why not different? Because they believe that that's the standard that we agreed on. So if we use the same standard, then it is good for everybody. If some state says no, I don't use the regular colors, I'm bored of those things, we'll use a different multicolor traffic lights. Then problem is what? Maybe the people in that state may get used to it. Suppose if somebody from New York goes to that state, obviously he doesn't understand what color, where to stop, where to go. Then obviously it will cause accidents. So it's the same way here, OLAP is the standard that explains, that tells that, suppose if you're building a reporting tool, a reporting application, what is the basic need that you need to have? What is the basic feature that you should have? So within the OLAP, they specify the best functionality a reporting application can get with the OLAP. So they defined a certain standard saying, okay, OLAP should have this, OLAP should have this, OLAP should have this, which means any reporting application you're developing, this should have this feature, like in a hierarchy, it should have the drill down feature, it should have XYZ feature. So they give a list of all the features saying, okay, if you are building a new tool, okay, this is all the features that you should have. Suppose say ISO standard. Suppose when your company is branded as an ISO, which means it is following all the guidelines of ISO. The same way, if OBIEE says it's a OLAP tool, which means it is following all the guidelines of the OLAP principles. Okay, so the reason I'm saying is any OLAP application is built on a multi-dimensional model. So one of the guidelines within the OLAP, like in the OLAP standard, is the source should be a multi-dimensional source. Period. Whatever the data that you provide to the reporting tool, not the anything. So whatever the data that you provide to the reporting application, like an OBIEE, okay, the source should be in a multi-dimensional structure, so that you can create very beautiful reports in the OLAP standard. Now, is our source in the multi-dimensional structure? No, our source is a OLAP, normal database. So our normal database is not going to really help us in building the reports or building the way that we want to look at the reports. So that is the reason the source can be in any format. Maybe I receive some data in a database, I may receive some data in a flat file, I may receive some data in XML. My data can be anything. So what I would like to do is, I would like to build a multidimensional model here based on all these tables. So I may have a lot of sources here, and where I will build my multidimensional model here, which is required for the reporting. So that is where my repository plays a main role. So building a multidimensional model that is required for the reporting based on the heterogeneous sources I have. Okay, so now why do I really need a multidimensional model? Because if I have to use a OBIEE tool which is created based on the OLAP standards. At the same time, if I have to create a very advanced reporting inside the OBIEE, I have to have the data in a multidimensional form. This is a mandatory. So you cannot avoid without creating a multidimensional model here. That is a standard where you cannot skip. So what if your data is having a multidimensional data? Suppose say my source itself is a from a multidimensional source like an S base or some OLAP cube or whatever. So your data is already in a multidimensional form. So you can simply use the same thing in the BMM layer also. You don't need to really build something new here because your data is already a multidimensional. Simply drag and drop. It will create a multidimensional structures itself. So the process is, if you're already having a multidimensional structure, use it as it is. If you don't have, create one. So we are going to build a multidimensional structure. So in any multidimensional source, the basic concept is you have the two set of tables. I can say two types of tables. There are two types of tables. Okay, where these two types of tables already they are related in a way. So one table we call it as a fact table. Another table we call this as a dimension table. So we have a fact table and we have a dimension table. We have the two types of tables. Now, obviously, they have a relationship. So in a it has a one-to-many relationship. So this is on the many side. Okay, this is n. This is 1. Okay, this is our multidimensional model. Any multidimensional model you take, so there is a two tables. One is a fact table, other is a dimension table, and the relationship between a fact and dimension is always a one-to-many. Can I comment data? Different database sources, Oracle. Yeah, you can combine. When you say combine, yes, you have one table from the database, one table from the flat file. Yes, it is possible. I mean, the moment you import the structures into your physical layer, you don't really care about where they come from. So they behave as a structures where that's the work of the OBIEE. How do we join them? How do we get the data? OBIEE will automatically take care. So you don't really need to worry about how do I join a database to a file. How is it possible? It is not directly possible, but the moment you import into the OBIEE, OBIEE will take care of pulling the data from both the sources and joining them internally and displaying the data to you. Right, so in a multi-dimensional model, you have two tables, which is fact table and the dimension table. So there could be many fact tables, there could be many dimension tables. That's pretty much possible. So most of the cases, there are more of the dimension tables, less of the fact tables. So like this. Okay, this is a dimension table. This is one more dimension table. So I have one fact table, three dimension table. So basically, I have to. I mean, we'll discuss more in dimension table. I don't want to really block this session with the concept of dimensional modeling, but the idea is we segregate the data as a two types. One is the numbers, other is the descriptions. So whatever that I want to analyze. So in other words, in a reporting, what do? We say sales, we say revenue, we say profit, we say margin, sales percentage, profit percentage, margin last week compared to the current week, last month compared to the current month. So we do all the calculations, right? Obviously, the reporting requires those calculations. We do all those things in a fact table. The numbers are represented in a fact table. The descriptions are represented in a dimension table. When I say descriptions, product. Suppose a product category, brand, those are all just names. Suppose say, what is that I actually want to analyze? I would like to analyze my fact with respect to the dimension always. Suppose say, what is the revenue for a brand? What is the revenue for a particular category? So which means I'm analyzing my numbers with respect to the dimension. It's always a fact and dimension. So you move all the numbers into one table. We call that table as a fact table, and you analyze that fact with respect to your dimension. Okay, we'll come back and we'll discuss more on this multi-dimensional model, because when I'm defining this BMM layer, I just wanted to give you a heads up saying, okay, we are going to build a multi-dimensional model. So I'm not expecting you guys to understand 100% on this model, but again, just we have to start somewhere, so we'll slowly understand step by step. Then there would be less application of the BMM. Yes, I mean, if you already having a data from a OLAP application, yes, the BMM layer is having less work. You don't need to really do much. It's kind of, plain repository which you are using. But, in some cases, most of the cases, not some cases, you may have a multi-dimensional model, but again, you may not have all the calculations that is required. So if you want to generate, you can create new calculation in a fact table, and you can enhance your model depending on your requirement. So if the model is pretty much perfect and you have nothing to enhance, yes. So there is nothing much that you need to do here. Simply drag and drop here. Your multi-dimensional model is ready. Okay, so now I'm going to create a multi-dimensional model here with a combination of fact and dimension tables. I right click here and I say new business model. It is asking me to create a business model. I can give any name, XYZ ABC. That's fine. But I can say model. I'm going to give a name which is a model BI sample. I'm just giving a name, model BI sample. So the simplest way is, if I have to show it to you, just drag and drop this one. It will automatically create a model for you. So if you think that makes more sense, then we can do it. Otherwise, we can also create the tables manually on our own. So I'll create one table manually and I will drag the rest of the tables automatically. Okay. So right click, new object, logical table. I'm going to create a table. Suppose say offices. I can create with my own name also, because these are the logical. It's like a view where we are not going to bother about what names we give. We give our own name. That's not a problem, because end of the day, we really care about the links between these tables. Okay, I have a logical table offices, and inside the logical table offices, I can create my logical column. Like, and I can create all the columns that is available in this table. So I can create all of them manually. So otherwise, if I don't want all this manual stuff for now to start with, because we just started it, all I can do is I can simply drag my base sample here. Now, based on the relationship that is available in these three tables, how they are related in these three tables, I have a model created which is base sample. Inside my model, my three tables are automatically used here. So if you see, there is a table called hash. So because the relationship is available is a one to many, where my revenue is on the many side, it has automatically identified my revenue table as the fact table. That's what I told you, right? So in a one to many relationship, the table that is on the many side is always a fact table. So since my revenue table is on the many side in our three table combination, so it is treated as a um, fact table, and the other two tables are treated as the dimension tables. So these are the two tables that is treated as the dimension tables. This is a fact table. Okay, let's not worry about the fact and the dimension. I'll take a kind of a dedicated session to explain you what is a multi-dimensional model and why do we need it and how do we create it. And it's a very detailed discussion we will have. But again, to just have a basic understanding, just as an assumption, saying when you create a BMM layer and a model, it creates a multi-dimensional model with a combination of two types of tables. One is a fact table, other is a dimension table. Fact table with the numbers, dimension table with the normal descriptive columns. Now, so there is nothing as such, that Oracle provides. Yes, but there are certain naming standards where we'll have, like, see, this is something, dimension is a underscore d underscore d underscore f, and you'll have some more naming standards. When we go forward, I will show you those things. It depends on, but yes, Oracle has their own naming standards when we use the BA applications. They did not mention anywhere saying these are the standards that we have to use, but again, so their implementations, they follow the standards. We'll also use those standards as we go forward. But again, there's no hard and fast rule. We have to go with that way. We can build our own standards. Every organization can have their own standards to implement. So now if you see here, I have three tables here. So I have my officers table and I have my revenue table, right? So and I have my product table. So these are the tables which I have with the columns. So now if you look at here, so I told like officers and the products are the dimension tables with the descriptive information, and my revenue table is a fact table with the numbers. So but if you see here, there's a lot of data available which I may not need. So if I think I may not require. So when I think I don't need all of the data, I can remove the unnecessary columns, which is suppose I need only units and the revenue. Out of my revenue table, I need only units and the revenue. Rest of the columns is something that I don't need. Maybe we need it. Probably we'll see it later if we need it. But otherwise, at this point of time, I think these rest of the information that is not required, because I would like to analyze only my revenue and the units. So I delete them. But if you need some of these columns, you can still keep it. That's not a problem. But again, see, you may get a lot of data from the sources. It doesn't mean that we have to use all the data, right? So I got rid of the data that is not required for me, because I am very clear I'm going to use these two measures in my reports. So, and again in the products also, if I think that some of the data that is not required, attribute one, attribute two, suppose if I think I don't really need those two, then I can sequence. I don't need these three, I can get it off. So only keep the data that you're actually going to analyze. So in the offices also, suppose I don't need a sequence assuming, and yeah, so I'll keep rest of them for now. Okay, so now I removed the unnecessary columns that is required for me, and again my data is also my table names and everything is not really good. Suppose if I want to rename my table to offices, I can simply say right click, rename. I simply make it as offices, because sample underscore product underscore D, it's kind of it's the same naming that is available in the physical layer, right? So I don't want to go with this one. I want to give a more business user look, because business user doesn't really want to see a sample underscore product underscore D. So it's a normal table standard. So but my business user want to see a descriptive names. So where by looking at offices, you should be able to correlate the business. You should be able to correlate the objects to the business. So when the business terminology what they use, we have to give the names that way. But again, so what if see, this table is offices underscore D, and this is offices. Now would I be able to get the data in the runtime? Yes. So if you look at here, offices, this is having a source where I have the sample underscore office underscore D. So internally, it is actually linking this to this table only, but we are given our own name. So you remember the concept of a view. In the database, we have a view. View is built on what? View is always built on a kind of one table or multiple tables. So I build a view based on the table. So if my table is, I think it's reverse direction. Okay, suppose I build a table. On the table, I build a view. So when I build a view, my view can have its own name, right? Maybe you can have its own name and everything, but still end of the day, where am I getting the data? I'm getting the data from the table only. Suppose to give an example, it's very normal thing. So if I have two tables, EMP and the DEPT, I have a table EMP and I have the table DEPT. Right, so there is a EMP table and there is a DEPT table, and I'm going to create a new table which is a EMP DEPT. So this is my view. I don't call it as a table. This is assuming that I created a view EMP DEPT, but I know that my EMP DEPT is created with a combination of EMP and the DEPT. But again, how do I know? So this is my database, which I have in between. I mean, inside the database only. This is the DB layer where so actual logic view. So, view logic. Inside the view, when I'm creating, what do? I create how this view is actually generated. Suppose saying, when I'm generating the view, I need to create view. I need to write a logic saying that, okay, the view data comes from these two tables, and the view columns are these. So I define this way. Suppose say now I say select star from EMP DPT. Select star from EMP DPT. Now, how does my query will be converted? My query will be sent to the database, and my database will verify the logic of the view. What is the logic of the view and what tables it is going to use, and it will generate a corresponding standard query saying select star from EMP comma DPT. EMP comma DPT, which means the data is from the two tables where EMP dot DPT equal to DPT dot DPT right? So we create the query like that. So now in our case, EMP and the DPT is the physical tables that is available in my physical layer, and EMP DPT is my model. So EMP DPT is my model, and EMP and DPT, both the tables are that is available in the physical layer. So how do I define the logic? The logic is the relationship that we define here. So now I have my source mentioned here. This is my logic. So based on the columns mapping that is available in here, that will automatically pull the data. So we have a flexibility, right? We have created our own name, our own combination here. So that's how we define our model. We use our physical tables that is available, and based on that, we define the uh, logical tables with our own name. When I say logical table, view is a logical, something similar here. My logical table is a table with my own name. I can create a logical table with any name, and I can create logical columns with any name. These names can also be changed. The bottom line is how these two are linked is important. Otherwise, the rest of the things is not cared about. So I can rename these products also with a different name. Say I simply give a name as a products. So if you want to give this a very simple name, I can give it as a revenue. So I created a model with a combination of three tables, and I have given my own names, and even for the columns also I can give my own names. Suppose say how do I rename all these columns? So inside the OBIEE there is something called tools utilities. Within the tools utilities there is something called a rename wizard. So rather than renaming column by column one by one, I can use this wizard. What does my wizard will do? It's kind of I would like to rename my wizard, I mean my business model. So add a hierarchy. When I say hierarchy, model and tables within the model, everything will be added. Okay, so everything is part of my rename wizard. So what is that I'm doing? I'm writing a simple rule saying, okay, convert to this, convert to this, convert to this. The rule will run automatically. Okay, so rather than changing all the names manually one by one, you can run this rule where it will automatically change everything. So I say next. So what is my rules can be applied? So my rules will be applied on all the business model, logical table, source folder, logical columns, everything. Okay, apply the rules on all the objects. Now, what is the rule I'm applying? First of all, what I would like to do, I would like to convert uh, all text lowercase, which means all the columns, like we have all the uppercase, right? So all text lowercase is something. I'm simply saying that all the text should be converted to a lowercase, and that is a one rule. So after this rule, what is that I want to do? Wherever there is a underscore, change each occurrence of underscore into a space. Okay, wherever there is an underscore, I would like to replace this underscore into a space. That is another rule. So the rules are executed in the sequence. So first all the model columns and everything will be changed to the lowercase. Then wherever there is underscore, the underscore is replaced with a space. And now I can specify first letter of each word is a capital. So when I remove the underscore, right, it's two words, right? First letter of each word is a capital. No, we cannot make our own rules. These are the predefined, and all we have to do is we have to use them. So, see, it's not kind of a programming application. Just something, but again, so you can say change specified text where you can change these things. So they have given the maximum possible combinations, But if you want to define your own, at least at this point of time you cannot define. They don't provide a mechanism to create your own things. So all you have to do is use them. Okay, so I have kept three things: all text lowercase, change occurrence of underscore into space, first letter is a capital. Say next. Now, if I apply these things, all these column names will change. So see, address key will be renamed to address space key. So you say A is a capital, K is a capital. So, and this is how your see, if you see, this is a BA sample itself is changed. First all is lowercase, and the first character, which is a first letter, is a capital, right? B is changed. So offices, now I have the columns changed. This also columns changed. So I can apply the rules and I can create my model. So I mean, we'll limit this here. So, and again, I don't want to go in depth on this because I don't want to get you confused. So this is my business model. Probably it doesn't really look good. If I want to put it as BA sample again with uppercase, I can put it as BA sample. So now the presentation layer. What is this? In this case, does OBIEE actually create a view object in the DB by the name of offices, products, and revenues? No. They are not stored anywhere in the database. They are a part of your OBIEE only. So they are nowhere in the database. But OBIEE will take care of using these views. It's kind of a structures only. They don't really create any physical objects. This is a structures, a logical structure that is in the OBIEE. And what OBIEE will do is, it will use the structures in the runtime. It will create the queries, which is a physical queries to the database and pull the data and use the physical data and that is written from the database and fill into the logical structures. So it will take care of the database activity also here. So it doesn't really hold any views. It doesn't really create any views in the database. The rest of the part is taken care in the OBIEE only. All it does is making a queries to the database and pulling the data from the database. And once you get a return, and again it will handle managing the data that is physical data into the logical structures into the views. So it's taken care by the OBIEE. Nothing is stored in the database. We don't really manipulate anything in the database. See, you need to understand the concept here, because if I start doing the changes in the database, and there is no point of using OBIEE, because I don't want to disturb the existing system, right? So many people may be using this database for many different purposes. If I go and create my own key, or if I go and modify my own thing, then I'm messing up the source data. So I have to use it as it is. I can say read only, then whatever that I can do inside the OBIEE, I can do that. That's the whole idea. Okay, so now I have my base sample model created, so I can simply use it in a presentation layer. So now maybe we're thinking like, what is the point of using a presentation layer when I already have a BMM layer, because more or less looks one and the same. Yes, I mean, it looks one and the same. We don't do much in the presentation layer, but again, we control data presentation. So that the name itself says presentation. So we use this layer to control what we actually display, or what we actually show it to the user. Suppose say some people doesn't really want, I don't want to show products to some set of people. I don't want to show offices to some set of people. Maybe I want to show product, but I don't want to show LOB and the type to some set of people. So the more in terms of presentation, it's more on the security perspective, or it's more on the representation perspective. So it's kind of suppose if you if you think it as an ingredients, like if when you're preparing an ice cream, right? So you need milk, you need sugar, you need chocolate powder, XYZ, and everything. That's where you call it the physical layer. You have all the different ingredients where you have a process to prepare an ice cream. So your business model is a process where this quantity of milk, this quantity of ice cream, this quantity of powder, this and that. You have a process here which prepares an ice cream. But again, you cannot really put ice cream in the hands of customer, right? So you pack ice creams with different things. You sell it as a cone, or you sell it as a box, or you sell it as cup, right? So that's where my presentation layer. So you have a lot of data here. You have a lot of information here, but you're organizing as a different subject areas where whoever is eligible to look at the data. Maybe I may have a users that is belong to different regions. Just to give you an example, so say I have one business model represented as a four 4 times. I can add them a number of times. So suppose here I can say BA sample north, assuming. So this is maybe I would like to use it for the north region. Suppose if I even if I don't want to have the same name BA sample, I can give my own name north. So there is a space. I can give my own name is north. Okay, I can give my own name which is south. I can give my own name which is east. West. So now my idea is it's the same data, it's the same model that I'm using, but for the West users maybe I may not be using the product table. I'm going to delete my product table. So people from West, whoever is having access to this subject area, they cannot really use my product information. Though my BA sample is having everything, but I am kind of abstracting. I'm not letting the other users know that information. So South users maybe they may not really look at my offices. Maybe North users they can look at all these three. Maybe East users they can look at offices, but in the offices you cannot look at particular company information and department information. Suppose they cannot really see these two columns. Okay. So now see what is that I'm doing? I'm displaying the data based on my choice. So now all I have to do is when I define the security in my OBIEE, I specify, suppose East, I specify the permissions where I can specify which user can actually look at this particular subject area. So that when I log in as a user that belongs to the East region, and I can see only these data. If when I log into the OBIEE as a West user, I can see only these data. So on one model, you are presenting the information differently to the different set of users. So for 4 regions, I don't need to build 4 models. One single model, but I'm presenting the data differently. So though I have everything here, but I'm segregating what is required to the what region people and who can access what. I am defining all those things in my presentation layer. So my presentation layer takes care about presenting the data in a way that is required to the user. So this is where I build my core logic, which is my core multidimensional model with a combination of data and the columns that is required. So yeah, you can apply the security in the BMM layer also to some extent, but most of the security is implemented on the presentation layer. Right, but again, in the BMM layer, you cannot control. You can control to some extent, which you can control on the logical table sources based on the user and all that stuff. But you don't really segregate like this because if you start doing the same thing in BMM layer, it makes no sense, right? Because all I want to do is I want to build a business model, which is a generic one, which is a common one to anybody, but segregate here so that I can reuse the same thing. If I make it as a specific, then obviously it is not reusable, right? So you cannot implement those features like in whatever that you did in a presentation layer because it is not built for that. It is a generic. We would like to make it as a generic so that I can make use of that generic and I can make it specific to the users. So if it is specific here, then what is the point of I cannot do it anymore, right? So that's the reason we don't do that in the BMM layer, but we can do it to some extent where we can go and restrict the data that is being retrieved from the database based on the user that I can do. But otherwise, it's more or less generic. Right, so my repository is ready. Physical layer, BMM and the presentation, I've built everything and I say save. So the moment I save, so it is asking for a check global consistency. What is a global consistency? Because when you're building something, right, so it's kind of compile. Suppose if you write a Java program and you say after writing the program you have to compile it, right? Why is this compile? The compile will verify if you have written the program based on the standards of the Java. So there is a Java compiler which will go through each line of the code and understand if you have done any mistakes or if it is created properly. The same way here, there are certain standards that we need to follow when we are building the BMM, when we are building the repository. Now, if I say global consistency, what it will do, it will verify if I have created the repository properly or not. If there is something joins I missed, or connections I missed, and relationships I missed, or logical to physical mappings I missed, column mappings I missed, anything if I miss, then it will automatically tell you, okay, boss, you missed so and so. So I say global consistency, yes. See, the model is consistent, which means it is good. There is no issues. Do you want to mark it available for queries? If it is consistent, then only we can use this repository. If the repository is not consistent, even if I try to use the repository in my server, my server itself will fail. So before you actually use this your repository for the reporting, your repository has to be consistent. I say yes. So since my repository is consistent, which is good, then I am saying that it's available for queries. Then it is changed to green, right? Okay, so which means it is ready. So if your repository this model is red, which means it is not consistent and you cannot use it. So there's a question somebody. Can the presentation be restricted the data level and the column level? Example, one user should not. No, we don't restrict at the data level, because we can only restrict at the column level. So suppose say data level, we can only restrict at the BMM layer, and we will only restrict the column. Now, suppose if I go to the column, I can say I can specify column. That's it. I cannot really restrict on the data level what data to be retrieved and what data to use. Any data control has to be done on the BMM layer. Okay, so my repository is done now. Okay, so now this is end-to-end where we created a repository which is consistent. All we need to do is we need to deploy this repository. So the other step that I told you, right? The second step is what? The second step is deploying your repository. So how do you deploy your repository? You have to use the enterprise manager, which is your a cloud utility where you can deploy it. So to do that, I have to go to the browser. So I'll open my Firefox. Always use Firefox, because that is the browser it works. Okay, so if I have to access my enterprise manager, the standard URL is http colon localhost colon my port. My OBIEE by default runs on is a 7001, but you can use any port depending on, I mean, when I say use any port, depending on whatever the port that your application is installed and deployed, you have to use that port. Okay, and the context is EM, enterprise manager. Say enter. So now it will ask you for the username password where you can log in. So my user is WebLogic and the password is welcome one. So user is WebLogic and the password is welcome one. Say login. Right, so this is your enterprise manager. Inside your enterprise manager, you have something called business intelligence. Within the business intelligence, you have something called a core application. So inside the enterprise manager, you have the business intelligence. Inside the business intelligence, you have the core application. We'll discuss about more on these servers. What are these servers and how they work. So it's still processing. Right, so this is your enterprise managers. You have multiple tabs, and one of the tab you have is what? Deployment tab. So I can go to my deployment tab. Now here all I need to do is I need to simply deploy my repository. So deploy my repository, and once the repository is deployed and your repository is available for the reporting. So I'll show you the deployment and the reporting part tomorrow, but at the same time, we'll come back and we'll also modify and enhance our repository and go back and see, we redeploy how it is going to work. And so we'll see more things online, offline. I'll explain those things in detail tomorrow. Okay. Okay. So any questions before we wrap it up? Anything that you don't understand here? Okay. So I believe we are good.